Hello students, today we are going to discuss our next article, that is relative permittivity and absolute permittivity. Relative permittivity and absolute permittivity of a medium. Now first of all we will discuss about the relative permittivity. Relative permittivity relative permittivity. Now students, to explain the relative permittivity of a medium, let us consider two similar point charges. Let the first charge is positive Q1 and second charge is positive Q2, and both are separated through the distance R, and both these charges Q1 and Q2 are placed in air or vacuum. Air or vacuum. Now these two charges are similar charges, and hence we know that they repel each other with the same force. Let the force acting on this charge Q2 is Fa, and charge Q1 is also Fa. Fa is the electrostatic force, Fa is the Coulomb's force, which exerted by these 2 point charges Q1 and Q2 on each other when they are placed in air or vacuum. Now, according to the Coulomb's law, we know that the magnitude of this Coulomb's force Fa is equal to 1 upon 4 pi epsilon naught, that is Q1 Q2 upon R square. Let the value of this Fa is equal to 5 Newton. हम मान लेते हैं कि ये जो Coulomb's force है Fa, electrostatic force Fa between these two similar charges Q1 and Q2 in air or vacuum is Fa, and this Fa is equal to 5 Newton. मतलब ये दोनों similar charges एक दूसरे पे कितनी repulsive force लगाते हैं? 5 Newton की. Now place these two similar charges in some another medium like water. So situation is positive charge, this is Q1, positive Q1, this is positive Q2, and the distance between their center is R, and now both these point charges are placed at the same distance, okay, but in the other medium. Let this medium is water medium. Medium is water medium. Now again they are similar, they repel each other. Let the repulsive force is Fw, that is Fw, equal force acting on both the charges, that is Fw, and this Coulomb's force Fw between these two stationary point charges will be equal to Fw is equal to 5 Newton upon 81. Means now 5 Newton is the Coulomb's force which is acting between the same two stationary point charges when placed in air or vacuum. And Fw is the force, Coulomb's force, electrostatic force between the same stationary point charges placed at the same distance but in another medium, that is water or water medium. Now the Coulomb's force Fw between them becomes, that is 5 Newton. 5 Newton means force between the similar two charges when placed in vacuum वाली फोर्स, जब वो वैक्यूम में एक दूसरे पर लगाते हैं, 5 न्यूटन वो फोर्स अपॉन 81. It means this Coulomb's force Fw, Coulomb's force when both charges are in the water medium, it decreases. Now force decreases. Coulomb's force decreases. Coulomb's force decreases by the factor of 81. Now, what is this 81? Now, this 81 is the inherent behavior of water, or we can say it is the property of water. And this 81 is a constant for water. Now similarly, now we place these two stationary point charges at the same distance in some another medium. Let us consider now we place this in the kerosene medium. Then this is the positive Q1 charge, this is the positive Q2 charge, and they are separated by the distance, same distance r, but now they are placed in kerosene medium. Placed in kerosene medium. Now again medium is changed, but charges are same, placed at the same distance apart. They are similar, hence again they repel each other with the same force. Let the force acting on Q2 is Fk, K for kerosene, and the similar force acting in the opposite direction on Q1, that is Fk. Now, in this case, the Coulomb's force or electrostatic force between these two similar point charges will be Fk, and this Fk is equal to 5 Newton. Again 5 Newton is the force when these two charges are placed in vacuum or free space upon 2. अब देखिए, जब हमने मीडियम चेंज किया, वाटर में रखा एट द सेम डिस्टेंस सिमिलर चार्जेस को, तो कूलम्ब्स फोर्स बिटवीन देम डिक्रीज हो गई. कितनी हो गई? जो वैक्यूम में उनके बीच में कूलम्ब्स फोर्स थी अपॉन 81 हो गई. जब हमने उन सेम चार्जेस को सेम डिस्टेंस पर केरोसिन में रखा, तो उनके बीच में जो कूलम्ब्स फोर्स है वो कितनी हो गई? वो हो गई, दैट इज जो वैक्यूम में फोर्स है उन दोनों चार्जेस में अपॉन 2. यहां पे हमारे पास दो नंबर आ रहे हैं, एक 81 एंड 2. 81 फॉर द वाटर एंड 2 फॉर द kerosene, and both these numbers are due to the inherent behavior of water and kerosene, or we can say due to the property of the water and kerosene. And these two numbers 81 and 82 are constant for a particular medium. 81 remains constant for the water medium and 2 is for the kerosene medium, it is also constant. In other words, we can say that 81 and 82 are two numbers, they are related to the medium. They are called inherent behavior of the medium. They are called property of the medium. And जैसे वाटर मीडियम के लिए 81 आया. Now 81 is a constant for water. लेकिन मैं एक और बात बताना चाहूंगा आपको कि 81 जो है वो वाटर के लिए कांस्टेंट तो है, लेकिन एक पर्टिकुलर टेम्परेचर के ऊपर अगर टेम्परेचर 17 और 18 डिग्री सेंटीग्रेड के बीच में है वाटर का, तो ये जो वाटर की वैल्यू है 81, ये कांस्टेंट रहेगी, ये 81 रहेगी. लेकिन अगर टेम्परेचर चेंज कर दिया जाए तो ये 81 नहीं रहेगी, 81 भी चेंज हो जाएगी. इट मीन्स this 81 is constant for a water at a particular temperature. अगर टेम्परेचर को हम एक पर्टिकुलर कांस्टेंट टेम्परेचर रखें तो उस कांस्टेंट टेम्परेचर के ऊपर वाटर की एक वैल्यू होगी, वो होगी 81. सिमिलरली एक पर्टिकुलर टेम्परेचर के ऊपर कैरोसिन की एक वैल्यू होगी, दैट इज 2. And both these values, 81 for water and 2 for kerosene, are constant at a particular temperature. And these two values are called relative permittivity. Where that is 81 is equal to relative permittivity. Relative permittivity of water. 2 is relative permittivity of kerosene. And here epsilon naught, ये यहाँ पे epsilon naught आया. Epsilon naught is absolute permittivity. Absolute permittivity of free space or air. Free space or air. No. Students, now different mediums having different relative permittivities and which is constant for a particular medium at a particular temperature. मतलब डिफरेंट मीडियम्स की अलग अलग रिलेटिव परमिटिविटी वैल्यू होती है और प्रत्येक मीडियम की रिलेटिव परमिटिविटी वैल्यू कांस्टेंट होती है एट ए पर्टिकुलर टेम्परेचर. नाउ वी नो हियर we assume that Fa is equal to 5 Newton. Fa is equal to 5 Newton. And this Fw is equal to 5 Newton upon 81. Now, what is the 5 Newton? 5 Newton is Fa. 5 Newton is here. 5 Newton. Fw means Coulomb force when between the charges when placed in water. It is 5 and 5 Newton upon 81. Now, what is 5 Newton? Fa. 5 Newton is Fa upon 81. 81. Now, Fa. Now what is 81? What is 81? 81 is the relative permittivity of water. relative permittivity of water. Here 81 is the relative permittivity of water. Now FA relative permittivity of water को मान लो हम डिनोट करते हैं R for relative permittivity and W for R for relative, W for water. Epsilon RW means relative permittivity of water. ठीक है, तो यहां से हमारे पास आ जाएगा therefore FW is equal to FA upon epsilon RW. Epsilon RW. Equation number 2. Let us consider this is equation number 1 and this is equation number 2, and from here we can write that is epsilon RW is equal to that is F A upon FW. Equation number 3. Now consider this. Now similarly we can write, we can prove that is Coulomb's force between the same 2 point charges when the placed in kerosene, that is Fk, it comes out to be that is Fa upon epsilon R K. This is equation number 3, and from here we can write that is epsilon R K. Epsilon R K क्या है? This is the relative permittivity of kerosene medium, and it is Fa upon Fk, equation number 4. Now from equation number 3 and 4, from equation 3 and 4, in general we can write that is relative permittivity. ये भी हमें क्या देता है? relative permittivity of water. ये भी relative permittivity of water. यहाँ पे Fa ये relative, ये this is the Coulomb's force between water. Coulomb's force between charges when placed in kerosene. तो now relative permittivity को हम लिख सकते हैं, ये relative permittivity आ रही है यहाँ पे Coulomb's force when placed in air or vacuum, और यहाँ पे Coulomb's force when placed in medium. अगर यहाँ पे relative permittivity वाटर की है तो वाटर मीडियम के अंदर Coulomb's force चार्जेस में, अगर यहाँ पर relative permittivity kerosene की है तो नीचे आ रहा है Coulomb's force between the charges when placed in that medium kerosene. तो ये relative permittivity है किसी मीडियम की, तो वो मीडियम का के अंदर दोनों चार्जेस में Coulomb's force आएगी. तो ये आ गया हमारे पास एक्सप्रेशन, दैट इज इक्वेशन नंबर 5. Equation number 5. Now this equation number 5 gives us the relative permittivity of a medium, and this relative permittivity of a medium, it is equal to ratio of Fa upon Fm. Hence we can define the relative permittivity of a medium is defined as the ratio of the Coulomb's force between the two stationary point charges when placed in air or vacuum to the Coulomb's force between the same two stationary point charges placed at the same distance in some medium. So this is the definition of relative permittivity of a medium in terms of Coulomb's force between the two stationary points. Now some points here we discuss, that is this relative permittivity. Note Note number 1, that is relative permittivity having no dimensions. No dimensions. No dimensions. Because it having no dimensions, because relative permittivity of a medium, it is the ratio of the two similar physical quantities, that is force. Now, no dimensions, hence, second note, this relative permittivity having no units. No units. Same ratio of same physical quantities, units भी कट जाएंगे. Having relative permittivity having no units, no dimensions. It means, number 3, it is a pure number. It is a pure number. And the relative permittivity of water is 81, relative permittivity of kerosene is 2, and relative permittivity of every medium is constant, but at a particular temperature. Hence, relative permittivity depends upon temperature. Relative permittivity epsilon R depends upon temperature. जैसे मैंने बताया, relative permittivity of water 81 है, लेकिन वाटर का टेम्परेचर अगर हम कांस्टेंट रखेंगे 17 डिग्री या 18 डिग्री, तब वाटर की जो रिलेटिव परमिटिविटी है, इनहेरेंट प्रॉपर्टी है, इनहेरेंट बिहेवियर है उसका, या उसकी जो प्रॉपर्टी है रिलेटिव परमिटिविटी, वो कांस्टेंट रहेगी 81 अगर टेम्परेचर कांस्टेंट रखते हैं, दैट इज 17 या 18 डिग्री सेंटीग्रेड. तो स्टूडेंट, दिस इज ऑल अबाउट द रिलेटिव परमिटिविटी. नाउ वी विल discuss the another article, that is absolute permittivity. Absolute permittivity. Absolute permittivity क्या होता है? What is absolute permittivity? Now, from equation number 2, students, this is our equation number 2, that is Fw is equal to Fa upon epsilon Rw, and you know that Fw is Coulomb's force between the static charges when placed at distance r in the water medium, and it is equal to Fa Coulomb's force between the same two charges when placed in air or vacuum upon epsilon Rw. Epsilon Rw क्या है? It is the relative permittivity of water. Now, we can write 1 upon epsilon Rw into Fa. Now, put the value of Fa from equation number 1 here. This is the equation number 1. Put the value, that is 1 upon epsilon Rw into Fa की value, that is 1 upon 4 pi epsilon naught, that is Q1 Q2 upon R square. Now, 1 upon 4 pi and epsilon naught epsilon Rw, that is Q1 Q2 upon R square, that is Fw. This is equation number 6. Equation number 6. Now students, see this equation number 6 and equation number 1. Equation number 1 or equation number 6, both are similar. Both are similar. Now FA, Coulomb's force between the two station point charges when placed in air. यहाँ भी Coulomb force है, same two charges में, but in water. 1/4 pi, 1/4 pi, Q1 Q2 R square, सब कुछ सेम है. यहां पे फर्क है तो सिर्फ इस चीज का, यहां पे एप्सिलॉन नॉट है और यहां पे ये एप्सिलॉन नॉट एप्सिलॉन आर डब्ल्यू. बट यू नो दैट दिस एप्सिलॉन नॉट इज ए कांस्टेंट. एप्सिलॉन नॉट इज ए कांस्टेंट. अब देखिए एप्सिलॉन नॉट फॉर एयर एंड वैक्यूम इज वैल्यू फिक्स है इसकी, दैट इज 1. नाउ वैल्यू इज 1, कांस्टेंट है वैल्यू. अब देखिए ये भी here epsilon naught it is constant, epsilon rw it is also a constant. Relative permittivity of water, that is 81, and this is epsilon naught, it is also constant. Both are constant. दोनों कांस्टेंट मल्टीप्लाई करके एक नया कांस्टेंट बनाएंगे. ठीक है, तो यहां पे एक नया कांस्टेंट आ जाएगा. तो हम मान लेते हैं, तो ये भी कांस्टेंट, ये भी कांस्टेंट है. इस कांस्टेंट को हम नाम देते हैं let this is EW. EW means relative permittivity, absolute permittivity of water. क्योंकि यहां पे absolute permittivity है तो यहां भी दोनों सेम है इक्वेशंस. ये absolute permittivity है ऑफ एयर की, तो ये absolute permittivity होगी किसकी? वाटर की होगी. तो absolute permittivity ऑफ वाटर को हमने EW मान लिया. तो यह आ जाएगा आपके पास epsilon naught, that is epsilon r w, that is equal to equation number 7. Equation number 7 आ गई आपके पास. Now in general we can write that is this is absolute permittivity of water. Absolute permittivity of water किसी मीडियम की, तो जनरल हम लिख सकते हैं मीडियम कुछ भी हो सकता है. इट में बी वाटर, इट में बी ऑयल, इट में बी केरोसिन ऑयल, इट में बी नाइट्रोजन गैस. तो मीडियम जनरल हम इसको एप्सिलॉन एम लिख सकते हैं. एब्सोल्यूट परमिटिविटी ऑफ ए मीडियम. नाउ दिस इज द एब्सोल्यूट परमिटिविटी ऑफ फ्री स्पेस एंड दिस इज द ये रिलेटिव परमिटिविटी ऑफ वाटर थी, सॉरी ये एब्सोल्यूट परमिटिविटी ऑफ वाटर थी. तो ये उसी मीडियम की रिलेटिव परमिटिविटी आएगी, उसी मीडियम की. इस मीडियम की एब्सोल्यूट परमिटिविटी, उसी मीडियम की रिलेटिव परमिटिविटी. तो मान लेते हैं रिलेटिव परमिटिविटी को आर लिख देते हैं. तो ये बन गया आपके पास. नाउ इक्वेशन नंबर 8. तो यहां से हमें डेफिनेशन मिल जाएगी. डेफिनेशन ऑफ दैट इज एब्सोल्यूट परमिटिविटी. तो यहां से हम डिफाइन कर सकते हैं एब्सोल्यूट परमिटिविटी ऑफ ए मीडियम. तो वी कैन डिफाइन एब्सोल्यूट परमिटिविटी ऑफ ए मीडियम इज डिफाइंड एज द प्रोडक्ट ऑफ द एब्सोल्यूट परमिटिविटी ऑफ फ्री स्पेस टू द relative permittivity of that medium. So here the definition of absolute permittivity. Now from this relation we can also, or we can write that is epsilon r is equal to, that is epsilon m upon epsilon naught. ये आ गया हमारे पास. नाउ दिस इज इक्वेशन नंबर 9. अब देखिए एक हमने यहां से डिफाइन की डेफिनेशन ऑफ रिलेटिव परमिटिविटी, एक हमें यहां से मिल रही है डेफिनेशन ऑफ रिलेटिव परमिटिविटी ऑफ ए मीडियम. ये इन टर्म्स ऑफ कूलम्ब फोर्स थी, ये इन टर्म्स ऑफ एब्सोल्यूट परमिटिविटी है. सो द सेकंड डेफिनेशन, according to this definition, the relative permittivity of a medium is defined as the ratio of the absolute permittivity of the medium to the absolute permittivity of the free space in which the two charges are placed. But students, relative permittivity of a medium is also known as the dielectric constant of the medium. मतलब किसी भी मीडियम की जो रिलेटिव परमिटिविटी है उसका एक दूसरा नाम है, that is known as dielectric constant of that medium. And this dielectric constant, it is denoted by K. Therefore, relative permittivity of a medium is equal to dielectric constant of the medium. Therefore, relative permittivity is epsilon r and dielectric constant is K. Therefore, epsilon r is equal to K, and this is equation number 10. So students, we have, this is equation number 5 gives us the definition of relative permittivity of the medium. Equation number 9 also gives us the definition of relative permittivity of the medium, and this is also the expression from the relative permittivity of the medium. Therefore, from equation 5, 6 and 10 we can write, that is epsilon r is equal to K is equal to F upon A upon M is equal to epsilon M upon epsilon naught. But student, here we can also write, that is epsilon r is equal to Fa is the Coulomb's force when the charges are placed in vacuum. So here we can write, that is F naught and Fm. So we will write here, this is equation number 5. So here we can write F naught. This is equation number 11. So students, in our today lecture we discuss about the two definitions, that is relative permittivity of a medium and absolute permittivity of a medium. तो आशा करता हूँ कि आज का लेक्चर आपको समझ आया होगा. थैंक यू वेरी मच.